crack of dawn, so I assume nobody's watching this.
It's okay, it's being recorded.
No,
Watching at home on TV.
okay, would all of those watching at home on TV raise your hands? We still don't have a two-way system. Relevant to this, I was trying to set up.
Because they're in their underwear, Bob.
Well, it's okay. We could get onto all sorts of side topics, like why video calls are a bad idea. So I did try to set up this morning, but I discovered I had to actually run a wire to connect this to this. I do have a wireless printer there, but this whole idea of running wires seems very strange. So yesterday I spoke about some of my influences here. Speak up? Or you weren't singing?
Yeah, you were echoing.
Okay, I'll talk like this.
Bob, they turned you down. You're okay, you can talk to me.
No, okay. So, I was fortunate to have a lot of influence. I mentioned, starting out in the SDS 940, after the 1620. Now, how many of you know Bucker Lamson? He taught here for many years.
I drove his car, I borrowed his car for some.
Okay, so as I said, he was a grad student. So I had the West Coast influence. I had the Multics influence. I also had the CPCMS influence. So those are all, I don't know how many people played in all those worlds at once. But I was also very interested in sort of more philosophical, psychological thing, which got me in more the AI world here. So at Tech Square, that building inside the Novartis building. By the way, I assume people are well aware of 545 Tech Square, now known as NE43, which was where the fifth floor was the Multics group, the second floor was the IBM group that did VM, the eighth and ninth floor were the AI lab. The eighth floor was the AI lab, the ninth floor were machines.
They were split. Some was in 545 and some was in 575.
Well, that was the Multics group was split.
Yeah,
But the
AI was in
540, it was in the eighth floor.
545.
That's what I'm saying.
But most of Honeywell ended up in 570.
Yeah, Honeywell did, but again, the AI ITS machines, again, we can easily get sidetracked. But I'm talking about sort of the influence. So one of the major influences was Seymour Papert. How many people are familiar with Seymour Papert? He was one of the people who helped, I know.
Why just kind of people don't know Seymour Papert?
How many people don't know Seymour Papert? Okay. Marvin Minsky? So they'd work together sort of on AI. Seymour came more out of the developmental psychology world. So his major influence on how people conceptualize ideas, think about language.
See if they know who looked at logo.
Oh, okay, the logo language. Logo and all? Okay. In any case, he kind of like one of his points is people don't learn new ideas. You get new people through each set of new ideas. And the other, and I also mentioned that J.C. Licklad was an acoustic psychologist. So I approach computers and everything not so much from mechanical, sort of, at multiple levels. I mean, I have been known to get out a soldering iron and build things. And though I'm not one of those who really like the smell of solder. But at the same time, I think of software more abstractly. So this is, the thing about the Multics project is that it really took computing from being sort of this low-level thing to thinking about the information utility and what we do with it. But then I jumped ship to the clinical decision-making group, which is another story. So a lot of this is background for how I think about computers, more abstractly. And also double E influence helps. So when I look at all these wires we're running around, I think, why are we running the wires? Why not just to find a relationship between this point and that point? But we'll get into that later. So let me do, this is a talk, I didn't prepare a talk specifically for this because not knowing the audience wanting discussion, but I did do this 4-minute talk for an event where I decided, instead of talking about the low-level details, let me talk about concept. So that's why I call this the age of software. What's this new literacy, and what is sort of, does software mean in a larger sense than just a mechanical process? And so I'll just get into it and see what I wrote. Okay, so why isn't this going to the next slide? That's the first mystery.
It's a software problem.
Is this
Oh.
an Apple product?
No, this one is actually not an Apple product. Yeah, I'll just manually force it to the next slide. Oh, I see, I have to say resume slideshow. Well, if this doesn't work, we'll go to plan B. But usually this pops up a control panel for me. We're going to try this once more, and let's see, slideshow. Yeah.
You get one of those actual slide projectors
Uh,
with a 80 slide, silver tray, and
No, the embarrassing part is I've gotten myself into edit mode.
there you go.
Yes, now it'll work. Otherwise, we'll just talk about it abstractly. Talks, go to talks, 2020, or 2019, what year is this?
2019, Bob.
I'm getting ahead of myself.
9 plus 50.
And Bob, while you're doing that, the Justice Department has announced an investigation of Google for implementing DNSSEC. I can't lie. I can't make this stuff up. What? That's exactly what they announced.
The code on a Sunday?
Yes, they wanted to get some attention, I guess, or not.
Or some, Trump's about to do something bad, so they want something else out in the news.
I don't
Okay,
think this is going to make it.
That's right. All the nerds will be distracted.
Oh, look.
okay. So I've gone to Plan B, which is basically just single screen. You're seeing the same screen I have, and we won't worry about it.
Bob, you just hit play.
I hit F5, which is play. It didn't do it. So we just go to Plan B. So the challenge I have is getting people to think outside the network. Because a lot of people think of the internet as just the network, and they miss the point. So one of the major influencing moves, a class I took in May of 1973. Mike Hammer, again, nobody here will remember Mike Hammer. You remember Mike Hammer. He wrote books on downsizing. There are a lot of interaction over the years, but this class in particular, we studied AlohaNet. Now, AlohaNet was a radio packet network. And the thing about AlohaNet is there's no real network in the middle. We just exchange packets. And because we had computers on the edge, or just directly, it wasn't the edge, they're just computers, you lost the packet to retransmit, you just programmed around it, and that's really the tradition of software. And that lesson is stuck with me, is that once you get intelligent devices and can have a conversation, you don't need all this complexity in the middle. And that also, the kid next to me in class put on a coaxial cable. And because we think of networks, he called it Ethernet. And the thing about what we missed was that it really wasn't a network in the sense of a standard telecommunications network. It was just basically, we did our own networking. It wasn't networking as a service. And in a long talk, I explained that that's part of the problem we have is language betraying us. that the words like network, we ignore the fact there are multiple meanings, so we confuse networking with network as a service. We use the word information to confuse Claude Shannon's use of the word for entropy with human meaning, even though they're not related, which has really made it hard to talk about these issues. So the thing I'm going to get to is the thing about the internet is that we can focus on the relationships without worrying about all the crap in the middle. And then we can separately worry about the crap in the middle. The problem with network engineers is they think their crap in the middle is important. And it's just plumbing we should be able to ignore. But you know, what? So now I'm going to go very high level, then I'm going to come back to this. So my argument, the reason the title is The Age of Software, is that there are a lot of concepts that we get from software, and we're basically ripping abstractions out of philosophy. We wrote math out of philosophies, we ripped natural science out of philosophies, we took psychology out of philosophies. Now we're taking abstractions. I don't know what philosophers have left. So to explain this better, how many of you, again, probably nobody here knows what Sherdler was. How many of you know what Sherdler was? Okay. Okay, I'm just doing an age check. This is like a mic check. And normally I don't ask the audience this, don't expect them to know. So Sherdler was Terry Winograd's doctoral thesis. You could type an English phrase like take this block, move it to this block, and it did it. And it was...
the point wasn't that it did it. The point was that it understood what you said.
Well, that's what I'm getting to. So there are two things. One, it was part of the operational understanding of what do you mean to understand. So philosophers would have all sorts of abstract things, but when you're programming and actually doing things, you have an operational, okay, I understand how I can do it. But then the other part of it, lesson that stood with me, is, oh, that's a parlor trick. Because the world is so constrained in everything, it really didn't have any, high level of understanding. And earlier, how many of you remember Weizenbaum's ELIZA or Doctor program? And Weizenbaum wanted to really show the limits on AI, how much was a parlor trick. And it turns out natural intelligence is a parlor trick too. So these, and the mention of Papin influence make me think of sort of how we understand things and everything. And the point I'm going to get to is how software gives us an articulate understanding of this.
Before you go, there's an ambiguity in that second line of yours, which no one in this room, except a few of us, would understand about your use of abbreviations.
Which one?
AI before ML. Just think of the physical instantiations many years ago. Never mind. Go.
Oh, acronyms get reused.
No. ML the machine. And AI the machine.
I forgot, but there was a KL,
KLs.
what?
They weren't KLs.
No, but later there was a KL. Language, the amazing thing about language is that we can communicate despite it. Okay. So if I were giving a real structured talk as opposed to rambling, one of the...
Ask how many people heard of him.
Okay, how many people heard of Von Neumann? Everybody heard of Von Neumann.
He invented the bottleneck. He's a mathematician who took credit for the PIN engineers that came up with the architecture.
He didn't take the credit. The person who wrote up the report.
Okay. Yeah, no, there are a lot of influences, but it's called the Von Neumann machine, and the basic idea is that you interpret numbers as instructions. And that's, again, when these things happen, you don't think of the full impact. It's a clever idea, say, rearranging gates and everything. And also, even use hexadecimal, which is, I'm only recently getting used to this newfangled hexadecimal, which we know octal is the real way to write numbers. But a 36-bit machine, obviously octal makes sense. In any case, so this introduced the other idea is autonomous execution instruction. But I also say this is meant for slightly less geeky oriented. Sometimes if you know too much, you get in trouble. Okay, but the idea these instructions can be executed autonomously is a very powerful idea. And one really, we've had mechanical machines. You'll find roots of all these ideas, but at some point they transform. So when you have a mechanical system like the Mechanical Turk, a name reused by Amazon, people did complex mechanical systems, but it was sort of one step short of what you can do with software, or one shift short. So computers are basically seen as great numerical calculators. How many Fortran programmers do we have here? Oh, actually, one aside I forgot to mention about that class with Bob doing Ethernet on broadband in 1973. I don't know if you're there. I wanted to basically put on the campus network. And I figured out broadband, you have an up channel and low channel. Too bad I didn't do it in 73 to connect the campus. You know, you look, these ideas are not, well, it takes a while, but Ethernet didn't become a thing until almost 10 years later. But the ideas, you know, the precursors are always there. So Fortran, and it's even with Fortran, people did symbolic programming in Fortran, but it's quite kludgy. So how many Fortran programmers do we have? Do you know what Fortran is? Okay. I just want to know how much history we study here. Actually,
Do you know what it means?
yes. Well, you mean formula translation. And one of my articles is about the history of software and how we solve, you know, how many of you know about automatic programming? We solved that problem to automatically generate programs. It's called Fortran. And then we discovered, yeah, it's not quite the hard problem. The hard problem is translating it until we reach today with machine learning, I call splat programming. We've just given up on programming. You throw it against the wall and you see what the pattern is. But that's the problem here. I get too off track. So the thing about these numbers is they're just meaningless symbols. And, you know, that's a very powerful concept, that they're devoid of meaning. And in particular, if we forget all the fancy numbers, just think of them as a string of zeros and ones. They have two remarkable properties. Well, more, but two. There's an old Monty Python scheme where you start numbering the points. You keep going back to the beginning. One is they can be regenerated. That unlike traditional analog things, it's either 0 or 1, which means you can go over any distance and it gets regenerated. The other thing is it captures nuance. So if you're representing things in numbers, and you have it exactly, you can maintain the slight one-bit distinction stay, whereas in analog systems, those become fuzz out. A little aside for the 7030 programmers in the house. Because floating point numbers are more analog and imprecise, you can run your programs in noisy mode or quiet mode. In quiet mode, it'll fill in the low digits with zeros. In noisy mode, it'll fill them in with ones. And then if the two numbers are wildly different, you know your calculation lost all meaning. That, by the way, in VisiCalc, I was thinking of adding a significance measure. So if you multiply numbers as you lose significance. But then I realized none of the spreadsheet used for calculation finance had any significance by the end of the calculation, and people didn't want to know that. If you ever at a presentation, you know, for business plan, and they look at the difference in low order digits of the last numbers after 10 years of guesses, you know. Okay, in any case, one of the major things, so John McCarthy, another name. How many people heard of John McCarthy? So he came up with two interesting ideas in 1958. One was symbolic programming in AI. The other, which I didn't mention, is time sharing. So, again, how many Lisp programmers are there in the house? Or Scheme? And okay, how many people know JavaScript was basically based on Lisp, filtered through Scheme? So, after a long quiet period where we got caught up in C++, and then, Java and C#, we returned back to the roots of Lisp, but with new techniques. In other words, we now have high performance because we've got another side. Because you have so much memory things, or all these programming is fundamentally changed. So that's another thing, is why is JavaScript now a high-performance language, and why is the idea of static compiling such a passé idea that for the 60s, with concepts like loaders and installing? Again, there's so many sides here. In this room, it's hard to keep track, but I want to now go weird. So what's an interesting digital system? So DNA is digital, which is very interesting. That means, it's all based on meaningless numbers. The closer you look at reality, the less meaning there is. So that's a fundamental philosophical concept. And the reason DNA has to be digital is that precisely those properties of basically regenerating what you have and preserving nuance. So if you have a fraction, develop an idea of a finger, it's all or nothing, you get another finger. The weird case we get half finger, but for the most part, if people have either 5 fingers or 6 fingers, you don't get a fraction of a finger. But the other thing, which, is that no particular gene is, there are a few exceptions, but for the most part, the meaning is in the whole set of genes, not in a single gene. And that's a powerful idea which we see recurring with the internet and everything, where when you send the best efforts packets, you lose a packet. Well, that packet is not all the meaning. You look for the whole set of things, and this applies in a lot of signaling and a lot of other cases. And this is one reason why I use the internet as sort of a laboratory for these ideas. Now, I might be getting ahead of myself. I forgot exactly which slides I do. But if you have a message between 2 endpoints, at the end, only at the endpoints you know what it means. In the middle, it's meaningless, which is why you can't do better than best efforts. But if you think of it philosophically, that's a very profound idea. The meaning doesn't exist between the 2 points. And that's part of what I'm going to get to, sort of the age of software. I often use the Ptolemaic Copernicus thing as this philosophical switch. We have not come to, and the thing about that is it displaced us from the center of the universe. Remember, the universe used to rotate around us. We're at the center of the universe. With Copernicus, the reason people were so upset at Galileo is that he displaced us from the center of the universe. Now I'm saying meaning is not fundamental. Now I'm saying meaning has only come from context, which is an interesting concept to come to terms with. So I did say, okay. I gave the next slide, save this on that. So this is why we could, instead of thinking of the internet as a network, you think of it as relationships, where you just share symbols and that's relationship. So why am I running this wire to this wire? Why am I leaving the microphone? Okay, the audio world, I need to stay near the mic. But if I take this, why am I running this wire through that when I should just be able to define identifier in here, define identifier in here, and that's it, and not worry about how it works in the middle. And, one of the things is a radio technologies are still based on the idea that you need a separate dedicated path for each message, because if you have dumb endpoints, you have to preserve all this. You don't know what's important about the message. You have to preserve the exact waveform between the 2 endpoints. What the lesson I got from AlohaNet was if you have intelligent endpoints, you can basically retry. It's the same reason. How many of you remember the early analog cell phones? It barely worked. But they were still so useful, you put up with them. You didn't need, what was important was the ability to communicate. You could program around it, and because some of us have intelligent endpoints, you can just ask, what did you mean to say? Of course, you can get it wrong, but that's another story. We can get it wrong even with a perfect channel. So all these ideas of like perfect channels and everything date back to an era when ERA or EROR, depending on your spelling, when we basically had the postal model, you're carrying a one-way message. When you have a conversation and you have the context now, things change a lot. Now, the first thing you can do, one example I use is once you have, this articulate understanding of symbols, you can now apply them to the physical world, and that's what's really exciting. Is that instead of basically shipping an object, you ship the identifier. Now, this is the way Amazon works today, but it really came home to me when my mother, this was back in the 90s, asked me to send a toy to Seattle, to Jared in particular. Normally I don't name, but since his father's here. So I told her, I'm going to get it from New York to Seattle in 1 hour. And I did, basically by sending a symbol instead of the physical object. And the important point to understand, this is a philosophical thing, is that I actually did ship that truck, because the important property of the truck was not the physical atoms, but was the model numbers of a red toy truck, and they were all fungible and interchangeable, so I just had to send the identity. And that's...
The recipient might disagree with you.
What?
The recipient might disagree with you.
No, the recipient never disagreed with me.
Jared's still happily playing with this imaginary truck.
But the thing is, you do this all the time when you order from Amazon.
Yeah, but there's a physical dependency in the end, which is it doesn't do you any good to ship the truck if there isn't an inventory in Seattle.
No, yes. No, my
Equal
point.
but not EQ.
No, it is the same, because even if I ship the physical truck, the post office could lose it. It's more likely it'll be inventory in Seattle than the post office, it'll get there.
But physical delivery does add additional meaning to really sending the symbols.
No, at the end, but the point is, the truck doesn't exist between New York and Seattle. That's the real thing, because when people talk about when you focus on the networking, they worry about how much bandwidth, how much capacity. You're transmitting ideas, you're transmitting references, you're not transmitting physical objects. Bits are not physical objects. You might use a physical means to send a packet.
But that was true with the telephone.
What?
What this says is that you don't want to live in the real world.
What?
What this says, Bob, is that you don't want to live in the real world.
No, I'm saying the point I'm making is this is the real world. The real world is language works this way. We talk about language, we're exchanging symbols. In other words, what I'm saying, the articulate understanding edge software is saying, this is why I bring up the Copernicus. Copernicus did not change a single thing about the solar system. There's no difference between the word solar system or the name of, or calling constellation Orion. It's the way we organize our understanding and see patterns. And the important pattern from Copernicus was you had a regular universe where the laws apply everywhere. And that's really what gave us the modern era. It wasn't simply that he made navigation a little better by shifting a reference point. It was all the implications of it. The point about software, it's giving us an articulate language to understand the world and to have concepts like autonomous execution. And we get to some like binding. This is what I'm trying to write about now, is those are very powerful ideas which, influence how we think of the world. The idea that meaning is not fundamental, things like good and evil are not intrinsic properties, is very unsettling to people. And it'll get you burned at the stake in many places. And the concept of money is part of an articulate understanding of money. A lot of people think money is gold, and that bitcoins are simply virtual gold. And that magically, if people didn't have anything to do with money, it would be better, as if money existed apart from people. So as I said, software, the solar system is just a construct. And, I think it was Archimedes said, give me a lever and I can move a planet. Well, we moved Pluto out of the solar system by simply rebinding it. It's that, and this is why, by the way, one class I took at MIT was accounting. is a very useful class because it really said what real accounting is finding measures useful for a purpose. So the accountant says, what answer do you want? The serious. It's really what problem you're trying to solve. That tax accounting is only one special case. And it's really about understanding that they're different measures. It is not intrinsic. And the same as, when we use language, that these words are simply symbols. The meaning is in our heads. And this goes back to some of the points about Papert. How many of you know who Piaget is? So Piaget was a development psychologist who looked at how children develop concepts. And it takes like 5 years to develop a lot of this concept to sort of understand the world, which is not very different than the 4 years it takes to college to develop some understanding. But it's about building a common vocabulary. But we still don't, because this is why I look at the word information. Engineers don't understand information. They use the words the same as if you're paying somebody for the work they've done, you don't ask how many ergs they've expended. The salary's not, aren't ergs the way we measure work? This is why don't let physicists in the payroll department. So I get ahead of myself. So this is where I'm talking about software as operational philosophy. And, so the idea is, what are these concepts and how do they apply? So, oops, this is a problem now. I move my finger and the slide moves, so we're out of order now. Basic literacy. This is why it's a small audience. So, how does just skipped a lot of slides. Yes. It's like how many people recognize a trolley belt symbol is used in many applications? Or the floppy disk icon for save. At least it's a 3-inch floppy disk usually, not the. We understand this world in terms of physical instantiations, but the world itself is very abstract. Let me see. Okay. Here's a problem with I took this slide and rearranged a couple of them last night late. What?
Maybe too late.
Well, yeah, but, at least I didn't have too many drinks last night, didn't have any. Okay, so what does this mean in terms of public policy? Well, one of the things is the entire telecommunications industry and business model is based on the idea that we need somebody to carry meaningful messages through reserved paths. That, just as railroads, basically railroads own the tracks for two reasons. One is so they can sell a service of carrying freight. There were no roads or anything, you had to rely on trains. The reason you had to rely on trains is, and all of these things have a long history. So why did we have railroads? We had railroads because the steam locomotive was too heavy to just be on roads and wheels, and was too expensive. This goes back, there's great books on the invention of the steam engine. So instead, you got rails, and there were dumb cars, and you put them in a train of cars.
The reason why we had railroads is people had goods that needed to get from point A to point B.
But the question is why that means, because we've been carrying them, what?
Railroads are more efficient. There were steam engines that ran on the road. You can't put a huge train together.
That's what I'm saying. It was a combination of the metal wheels and the train, yes.
But previous to that, there were toll roads and canals all over the place that you paid to go use those.
Yes.
It's hard to steer something that's a mile long.
Yes.
That's another artifact. It's not any different from canals paying for passing a canal and passing a toll road.
No, yes, and the Erie Canal lasted about 3 years before the river.
I'm talking about the big thing of England, in Scotland, where they built it over the 1700s.
What is 1700s? What about the Chinese canals? We can go through a lot of history.
I don't know what they're talking
What
about.
about what's on Mars?
Yes, the canals on Mars. Those are the real issue. Okay, okay, this is smart aleck audience. Okay, but you're right. We had the number of reasons trains came together with a heavy, expensive locomotives on rails with a long train of cars. So once we got, very light engines, you can have autonomous vehicles which can use the open road system. And we didn't need all the artifacts. We have intelligent, devices. Yeah.
Bob, we could have a long argument on that because the one train pulling lots of cars on a track may be much more economically and energy efficient than having lots of autonomous vehicles moving around if what you're moving is 400 cars of grain.
No, I agree. No, there is, again, you have to be careful with the analogies. If all the cars are going to the same destination, it's more efficient. This is the same thing as people defend broadcast TV. As long as everybody's watching the same show at the same time, broadcasting the same content to everybody is more efficient, if that's your measure of efficiency. But, the reason it's much less efficient is the purpose is not so we're all in lockstep watching the same screen. It's to serve people. And for people, it's more efficient to watch things when they want to. And that's, I think, an important point you're bringing is the word efficient is one of those traps, same as quality of service, all these. People implicitly assume a context, which gets back to the articulate understanding of context being, an important fact where the meaning is coming from. So we talk about efficient use. You have to be explicit and say basically, what's your context and what's your measure of efficiency. So this is why all the streaming and stuff, people are saying it's too inefficient. The other part of efficiency is, another example to use a telecom thing. The phone system was going to collapse in the early 90s, or the late 90s, because modems basically tied up the phone network. Everyone had a reserve path and locked it down. And the solution was just accept native packets, best efforts, and suddenly you had a more efficient use of the shared infrastructure. But to get that efficiency, you also have to accept one other idea, which is that you have to discover what you can do with the available things. In other words, if the efficiency is a measure of how much we can do what we used to do, it's less efficient because reserve paths meant you could just have a video stream, no recovery. You can calculate the precise capacity. But you also got a busy signal. If instead we can't guarantee anything, so there I use the example of voice over IP. That voice over IP was, and the other theme here is new ideas are discovered rather than invented. So voice over IP, people talked about doing it, but it was all in more efficient version of traditional telephony. People did, one of the origins of voice is Vocaltech, which did a hack that worked over the local network. And then they discovered people using over the wider internet. And the reason that worked was the economic model would have not have supported that. People built no infrastructure for VoIP, but they built it for the local web. And that was then repurposed for doing voice over IP. It was the same as, evolution works by repurposing things. I didn't mention it, but, if a jawbone can detect vibration, you discover hearing. The concept of hearing wouldn't have existed if we didn't accidentally discover listening to vibrations are useful. Then we develop a whole, set of organs and things around hearing once we had the accidental discovery. So part of the problem, going back to efficiency, is you're trying to be efficient against future, opportunities. You want to maximize opportunity. So that's one of the concepts. The other thing is, I'll get to a concept of binding, where the fact that we can have an articulate way to manipulate symbols and not physical objects has a lot more implication than just making it more efficient to ship physical things. And if you combine that with the concept of the autonomous execution, we start to get more of today's use of computers. But the idea, again, that all they have to do is define a relation between this and that endpoint is very powerful. Then this goes back to the policy things, and arguably is that so I often use Route 1 as an example. Like there's a whole nother story about how he developed route numbers. The short version, or the actual, I don't know, short, a company was printing routes with pictures of buildings and said, you turn left of this building to get there. Then they realized you could paint numbers on the roads. We didn't have to have all these pictures. You just say, follow the ones. And eventually that became the signpost, Route 1. Now, there are two things about the story. One is that Route 1 is a virtual route. You don't pay for Route 1, you pay for the physical facilities along the path. So it's not like a railroad model. Route 1 is not like a track. It's just like more like, well, it is a road, but it's a virtual road. So you don't pay for that.
It may move, but there's a physical road that underlies.
No, Route 1 is the virtual road. It's made out of physical roads. That's an important distinction. And today, Route 1 is in these, okay? That you just, when you use your map application to get a route, that's a virtual route no different than Route 1. It's just, again, you don't have to all share the Route 1. You can now have your own. What? No, it's just not articulate. It's just not articulate yet.
Actually, I think he's perfect. Yeah.
You're right. It's too. Okay, we won't go into all the philosophical implications of that. But you think about the economics of Route 1.
By the way, Bob, the last time you gave this talk, were you heckled by the audience this much?
Well, this I'm thinking of treating as a different small audience, and also I didn't do a careful slideshow where I focused on this because it was more this philosophical idea of meaning not being intrinsic that I want to emphasize.
But I think your point with Route 1 would be better made if you pointed out that the roads that were labeled Route 1 already existed.
That's my point. And what's confusing about the story, what's confusing about the story is that the interstate highways, the interstate defense highway system,
National Defense Highway.
yes, that's a whole other story how we got to that, but those are explicitly built with numbers and everything, so they're not really like the Route 1 story. But they're an overlay and optimization.
Remember, before there was Route 1?
Yeah.
Okay, we had a different abstraction for it, at least in many places. Boston Post Road.
No, yes, no, you're right. That's a good point. We had the Boston Post Road, which was cobbled together out of whatever routes were available.
I think your actual point is that two different people in 10 years apart could drive Route 1 and be actually separate.
Oh, they actually did move Route 1. I've lived on Route 1.
It's this symbolic concept of Route 1 that needs to be mapped to a railroad system at any point.
When it was paved, there's new asphalt now. So it's really a new road.
Step too far.
Okay, yes. Okay, we won't.
Something about stepping in the same stream twice.
Okay.
He's arguing that meaning is contextually dependent. I think you just proved his point.
Yes. No, but that's what I'm saying. All these things, the point about the articulate understanding is if you go back, you can see precursors to all this. You can see we're using some of this. Simple example of binding is VP of engineering is bound to a particular person. But when we have an inarticulate understanding, we'll give the email, we should have an email address, which is VP of engineering. Instead, we give the person who happens to have the job, and then you've got to change all your address books when the person changes. When you have an articulate understanding, we can have an abstract identifier for that purpose.
I think sctv.mit.edu has been rebound many times.
No, well, some people have a better understanding of this concept.
That depends on the department of the office.
But, so this is a light switch I actually use in my house. I just have to bind these identifiers to the light, and in theory, that's all it takes. Now, underneath, I have to program around a lot of crap and everything, and it's an interesting discussion there. But
Have you labeled your switches yet?
yes, they're labeled.
No, he doesn't mean the ones there. He means of the physical.
What? They don't work anymore. Don't worry about
You
them.
have to charge your light switch.
I know, I use USB power. There's a whole nother discussion about going back to DC power.
Drop your light switch.
Now, the
You
problem
can be in big trouble.
No, I have extras.
if you walk into his house,
You can't turn
nobody
on the lights.
knows.
I have, it's great.
No, but, yes. Well, first, I suffer so you all don't have to.
Bob, there's another person who made that claim.
Well,
And he was on a cross.
Yes, yes,
He did make the claim, the people who followed it.
right, they made the claim.
The more interesting finding is like the 415 from Buffalo. The 415 train from Buffalo, right? What is that?
Yeah, no, but that's what I'm saying, and this is why I get upset when people confuse direct flights with nonstop flights. Because the direct flight is a binding of a code to a route, whereas a nonstop goes between points, but people miss that. I mean, that's the other problem with binding language, is people learn by the examples. They don't go to the definition you want. So this is why Pandora is radio. Because at one point, the business of radio was matched to broadcasting music because that was all it was good for. So economy of language, you think of the radio business as music. I go to CES, I ask about radios, and they get confused because even though it should be, technologists there, they think I'm talking about the music business. And where this comes back is the word telecommunications, where that word communications has been unbound from what we mean by speech. Because once that was the only way to send a message over a distance. So now we have a federal communication. What?
I don't think there are very few people, you should ask how many people in this room understand how the telephone network used to work, like when you were growing up.
How many people know about red green?
Why don't you just talk about DormNet? Because that would be, dorm line. It would be punching the covers.
You mean what became the 258 numbers?
Yeah, 225.
225? That succeeded to, okay. Yeah, we could go, the phone system, I mean, this is where relative phone analogy, a lot of the same ideas, you lock down a repository. As I said, this can be a full semester, class and all this. For those who took it.
6 credit seminar.
Okay. In any case, we get.
It doesn't exist anymore as far as I know.
Where was it, the London course? Yeah, it's great.
Yeah, no, but more Berlin and all this. No, you learn a lot about how, but we can get very, very far off track.
Why don't you just explain to them for 10 seconds how it actually worked, that when you talk to someone, okay, you actually talked over a single wire.
Oh, okay. No, actually, that's good. So let me go brief through this. So the original system was based on the original telegraph system. You create a metallic path between the two keys, two endpoints.
Was the ground, because it was a one.
Okay. Well, eventually it became a two. Yeah, and we can talk about electrocuting. We can talk about electrocuting cows in Wisconsin too, which is a problem with that system. So then, when Al Bell basically disobeyed his father-in-law and used the money to develop this telephone which never worked, then when he stole the idea from Elisha Gray, who then retired to Newton, that became the talking telegraph, which still had the metallic wires between the two endpoints. But it would actually work less well than the telegraph because you had to preserve this analog signal over long distance. Comes Claude Shannon, who says, well, what if we use this idea of bit streams and we encode it as bits, but they ran it in analog telephony emulation mode, which meant reserving still a path on the wires where the relays all connected it between the two endpoints. So that basically still the metallic path, but now it carried digital encoding rather than analog encoding, so you can preserve the signal.
You just skipped about 70 years in there.
Oh, you mean this? There was a stroke.
The idea of the physical instantiation.
Well, he's already burned half an hour.
Oh, okay. There was a Stroger switch, which was, what?
2-minute warning.
Well, I started 4 minutes late, so I'll take another 2 minutes, take half of that. Okay,
Let him go to the next speaker.
yeah. Who's the next speaker?
Rihanna will be the next speaker. I do not see her.
Okay, then I'll keep, okay. So the Stroger switch was a funeral director Stroger was a funeral director whose calls were being intercepted by the operator and sent to his competition because she was the wife of his competitor. So he developed a mechanical phone switch which set up the path dynamically through the relays, but it set up a physical path. So it just established a physical path electronically. But the reason...
Pause for 1 second. Why don't you ask the people who don't actually know what you're saying whether they understood what you're saying?
That's important. The point is, you had a path between the 2 points. You had a reserve. Yeah, we go all night. You're asking. I'm saying the main point is we had a reserved path which preserved the exact signal and waveform from one end to the other end, and that was the key idea of the Stroger switch, not Stroger, of the analog path, and that's what Claude Shannon emulated and developed all this technology. The big unfortunate thing about Claude Shannon's work is he used the wrong word for entropy. He used the word information. No, but it's bedeviled the current policy. It's the heart of the current policy is that was an abstract measure of efficiency against an abstract measure. It has nothing to do with what humans mean by speech and meaning. The big breakthrough then with voice over IP is discovered all this isocronous stuff we didn't need because we can actually make up for it basically even, with intelligence both ends.
We should wrap up so that Liana can
Okay.
set up her talk.
In any case, so the points which I never got to most of the hecklers. Number one, the big idea is software gives an articulate understanding of abstractions and meaning, and we really haven't even started to come to terms with that. So that was the main thing. So I'm going to go through their concepts of binding and other things which we can use. So that was the thing. One of the immediate implications is think of the internet as a network. It's not a network. It's really a first laboratory study in how do you focus on the relationship between the endpoints. And there, our public policy has not come to terms with the fact that we don't need sort of the equivalent of tracks between the 2 endpoints, but we need to pay for the facility separately for the relationships. And this is why we have a Federal Speech Commission who tells you what words you're allowed to use because they're confused about what the word communications means. So I'd ask them questions, but I'm being kicked off the stage. By the way, if anybody wants, I brought a label maker. If anybody wants to get that working for